So we've been focusing primarily on internal validity, or how real or truthful the study is internally. I want to turn it around to the other side, which is replicatability, generalization, and the real world. In other words, once we found an effect, how can we make the argument that that effect would be found in others? So to be important, a study must be replicatable. And that is one of the facts that we've focused on internal validity, that all studies need to provide enough information that someone could effectively rerun the study. Maybe not exactly using every element. So for example, we might simply give some examples of the measures that we used instead of the entire measure, but it's still enough information that someone could easily replicate the study. And for a study to truly be meaningful, it needs to be replicatable. In other words, if the study by its nature could not be replicated by any other researchers, then at that point, it really isn't meeting the requirements of scientific methodology. So for us to be able to observe the world systematically, others need to be able to observe the world using the same systems and systematic processes. So there's three broad types of replication studies. There's direct replication. So this is when someone takes a study and basically tries to be as close to the original study as possible. Same variables, same operations, or at least very close to those same operations based on the original study. So in this case, for example, if someone did a pre-test, post-test, two-group design, we would also do a pre-test, post-test, two-group design. We'd use the same manipulations of the independent variable, and we'd use the same outcome in the pre-test and post-test, or close as possible to it based on the original study. We wouldn't be adding anything, we wouldn't be subtracting anything, and honestly, for a direct replication, we're often going to be trying to use the same population. So for example, if the study was a Midwestern psychology department undergraduates, we'd probably try to use the same group. So we're basically seeing if we run the same study, effectively keeping things very similar or the same, would we find the same results? The next is a conceptual replication. These are much more common. Same variables, different operations. So in this case, we're still looking at the same concept. So for example, we might be still looking at whether someone is found attractive if they are randomly assigned to view photos, or if they know ahead of time that the person shares a birthday with them. In this case, we might change some of the variables. So the way we're actually having the manipulation. For example, in the first study, we might have actually been using pictures. The second study, we might be using physical descriptions. In the first study, we might have asked people how much they like the person. In the second study, we might ask how much is the person likely to be dated. Those are examples of similar variables. So we're still looking at the impact of learning if someone has been born on the same date as you and our perceptions of attractiveness. But how we're doing it, how we're manipulating it, and how we're actually measuring it, and potentially who we're doing it to. So for example, the first study might have looked at college students. The second study might look at high school students. The third study might look at middle-aged people from a certain age range. That would be a conceptual replication. And then there's replication plus extension. So we're still looking at the same variables or the same conceptual variables. So thinking of replication plus extension, this could be direct replication plus extension, or it be conceptual replication plus extension. We still have the same variables. They may be the same, they may be measured and manipulated in the same way, they may not. However, we're adding additional variables. So for example, the initial study might have looked at the effects of driving on a cell phone on collisions in a particular sample. So they basically manipulated whether someone was randomly assigned to drive without a cell phone or drive while on a cell phone in a simulator, and they recorded the number of collisions. And this was basically the initial study. A replication plus extension might do that same study, but then also, after people have practiced for 3 days, have them do it again. In this case, we're gaining more information. Someone might say, well, what you're actually capturing was that people that aren't experienced with driving with cell phones are more accident prone, but what about if they're experienced with it? And what we find is that experience does indeed reduce the number of collisions, but the effect is still there, the difference. Driving only still results in less collisions than driving on a cell phone. So we can also look at this as replications, in other words, different people or the same people running the similar studies. And this is an example of looking at a broad set of studies. So this is looking at the results of the impact of violent video games on behavior, experimental studies only. So this is where people are brought into a lab, are exposed to either a violent or non-violent video game, and then their aggressive behaviors, pro-social behaviors, or empathy for others suffering is measured. And what we generally find is a trend. So we have 45 studies that experimentally looked at this, simply measuring some form of aggression. We had 8 studies that looked at basically measuring whether this impacted pro-social behavior, and we did 11 studies that exampled empathy for other suffering. Now, if we really wanted to know how much this replications, and so in this case, we have over 60 replications, we're looking at also, is this all being done by the same researchers? It usually is valued more if replications are being done by other researchers at other institutes. It's just worth a little bit more. That's not to say that you can make a career researching the same topic in many different ways. You definitely can. But if other people are also researching it, it helps to add to the overall perception that this is in fact an occurrence. Think about this: if the 45 studies for aggressive behavior were all done at the same university with the same students by the same professors, it would be a little bit harder for us to go, would we find this at other universities? Would we find this in other studies? Would we find this if other people researched it? There might be something about that university, that might be something about that research lab, or it might be something about the perceptions or beliefs of those particular researchers. So again, if we look at these 45 studies and they are being done at multiple universities in multiple labs with multiple populations and multiple groups of people, there's just more weight to what's being found. Within these studies, we can look at the total participants. So we have 3,464 participants in the aggression behavior studies across those 45 studies. We have 875 across the 8 pro-social studies, and we have 537 across the 11. Now, this doesn't tell us who these people are, what their backgrounds were, and that is also information that we want. But we can also look at then the average findings. So the average positive value mean of violent video games grouped order, grouped scored higher. So generally we find that we see an increase in aggressive behavior when exposed to violent video games, a decrease in pro-social behavior when exposed to violent video games, and a decrease in empathy for other sufferings when exposed to violent video games. So this starts to make an argument that it's not a single study looking at it in a single way, it's a general trend. Now this is just looking at experimental. The next jump or phase would be, do we find this in the real world? Are we actually finding evidence that exposure to lots of violent video games results in people being more aggressive, less pro-social behavior, and less empathy? And one of the ways we can look at that is through another technique that we use, which is replication by independent researchers and meta-analysis. So I already kind of talked about that replication studies carry more weight if they're conducted by different researchers. Another way we can do this is actually a statistical analyzing of all of those additional studies. This is referred to as a meta-analysis. It averages the effect sizes across all studies on a topic and can adjust for biases, for example, publication biases, experimental biases versus non-experimental biases, and there are strengths and weaknesses to a meta-analysis. So you can still kind of cherry pick which studies you're looking at. And one of the biggest weaknesses of the meta-analysis is often what's called the publication bias. In other words, if you did a research study and it was a very well done study and you didn't find an effect, it would be harder to get it published than if you did a study, it was a very well designed study, and you did find an effect. So whenever we do a meta-analysis, when we say 45 studies, we're generally referring to published studies. So for a meta-analysis to get around this, a lot of times it takes the authors of the meta-analysis to do a lot more digging to find unpublished studies that also supported this. And that can be one of the variables too, published versus unpublished effect sizes. So again, there are strengths and weaknesses, and most of those weaknesses involve how the data is collected for the meta-analysis. The strengths are really being able to look across statistically an entire group of replications to find, are we finding a consistent bit of evidence that this trend in human behavior exists? So just a review on external validity: no matter what we've done to identify a population, recognize it's generally a population, not the population. So for example, if I say, well, I've done a random sample of college students, well, that's a random sample of college students, but that population is not all college students. It's the population of college students that I have access to. And honestly, it isn't all college students even that I have access to. It's probably college students that are specifically taking an introduction to psychology course. So we always want to recognize the potential issues of where did our participants come from. Even if the internal validity, we did everything right. We've done strong matching or a random assignment with a large population or a large sample. We still have to recognize when we're talking about external validity, does that sample represent the population and what was the reality of that population? External validity comes from how, not how many. So a lot of times people think that the more people I have in the study, the more externally valid it is. This is not true. The more people you have in the study, the more likely you are to find a statistical effect. So statistics are impacted by popular or sample size. However, external validity comes from how you conducted your study and then how you're making the arguments that it can be generalized. And just because a sample comes from a population does not mean that it generalizes the population. So even if we used random assignment, if we identified everyone in our population and then randomly selected them to be in our study, did any of them refuse? At that point, again, those refusals become an issue with external validity. So to be important, to basically have impact on the field, generally studies do need to have some form of external validity, but not always. We do generally want to generalize to other participants as much as possible, or at least acknowledge how generalizable our study is compared to other studies. We want to be able to generalize to other settings. However, does a study have to be generalizable to many people? Not necessarily, especially if we're looking at an experimental design where we're looking at the effects of basically causation. We've held everything constant to ask, is this truly an effect that we can cause? In that case, our focus is not necessarily on external validity, it's on internal validity. And if we find it and publish it, others may come along, or we may come along and do additional studies looking at more external validity. So does a study have to take place in a real world setting? Absolutely not. It really comes down to what is the purpose of the study. Are we trying to establish an experimental causation? Are we trying to take an experimental causation and ask, does it happen in the real world? And this kind of gets the idea of theory testing mode versus real world mode. So for example, the Harlow studies were the studies that looked at basically attachment style of young monkeys. And what they found was that by behavioral standards, and this was done in the 1950s, by a behavioral standard, the assumption was that attachment is formed by the presentation of food, stimulus and response. You provide food, you get the response, which is basically the monkey is no longer hungry, and because of that association, also you get fondness, you get attachment. And so what Harlow did was basically set up two monkeys. Both of them, one of them provided food, one of them provided warmth and comfort. So one of them was a cold, sterile cage that provided food, and the other one was a warm blanket with a smiling face. What he found was that monkeys tend to spend 24 or 23 of their 24 hours clinging to the warmth providing monkey. Now, this is not necessarily going to be a breakthrough because you could still say, well, we just got what the stimulus was wrong. The stimulus isn't food, the stimulus is warmth. However, it did kind of poke a hole in the true behavioralist, the entire world is a stimulus and response, and started to create additional theories. Now, there was, again, a lot of replication of this study, including conceptual and replication with additional variables that further refine this. Another one example is parents as grammar coach theory. So this idea is basically that if you teach parents to talk to their children in a very precise and kind of higher pitch way, it has positive impacts on the child's learning development, language skills, and actual abilities going forward. And the initial studies of this looked at it in a pure lab setting. Children were brought in, parents were taught, and then parents were basically creating this way of talking to their children within a lab setting. And they found a fairly strong evidence that there was support. Now, again, beyond that theory testing mode, then parents as grammar coach theory was expanded to look at real world settings and do we find this effects in the real world? So does a study need to be generalizable to many people? It really comes into what are you trying to do? If you're trying to actually make an argument of generalization, if you're making frequency claims, in other words, if you're talking about how often this is found in the real world, if your goal is to make claims about populations or general human behavior, then the real world really does matter and external validity is essential. However, if you're simply testing a theory, association, or causal claims, if your goal is to test a theory rigorously to isolate variables, if you're prioritizing that internal validity, artificial simulations situations may be required, and the real world comes later. External validity really isn't the priority in that case. So just kind of putting it all into one big chart, we're integrating the three types of claims using the four big validities. So again, our four validities are construct validity, statistical validity, internal validity, and external validity. If our claims are frequency claims, in other words, nearly 60% of teens text while driving, the construct validity is going to be how well does the researcher measure the variable in question. Statistical validity, what is the margin of error in the estimate, and have you made an argument that it is 60%? Internal validity, frequency claims are usually not asserted causally, so the internal validity is not as relevant. And external validity, to what population settings and times can we generalize this estimate? How representational is the sample? Was it a random sample? So for example, just as a reminder, if we found that nearly 60% of teens text while driving, we do need to ask, where was this study done? In other words, was this in the European Union? Was this in the United States? Was this in Japan? And we need to ask when it was conducted. So a study that was done in 2005 may not well apply to 2025. If we're making an association claim, shy people are better at reading facial expressions. Again, our construct validity, how well has the researcher measured each of the two variables in the association? In other words, what is the construct reality of those variables? Statistical validity, what is the effect size? How strong is the association? Is the association statistically significant? If the study does find a relationship, what is the probability the researcher's conclusions are a false positive? If the study finds no relationship, what is the possibility the research was missing the relationship? In this case, internal validity, people who make association claims are not asserting causality, so internal validity is not as relevant to interrogate. A researcher should avoid making a causal claim from a simple association. And we've talked about that as well. And finally, external validity. To what population settings and times can you generalize this association claim? How representational is the sample? And to what other problems might this association be generalized? And finally, we have the causal claim. Music lessons enhance IQ. How well has the researcher measured and manipulated the variables in the study? So very similar. Notice that these really don't change. Construct validity is pretty solid across these types. Statistical validity, what is the effect size? Is there a difference between groups and how large is it? Is the difference statistically significant? And we would be also asking, did we miss an effect or are we making a false claim? Internal validity is very important. Was the study an experiment? How did the study achieve temporal precedence? Does the study control for alternate explanations by randomly assigning participants to groups? Does the study avoid several internal validity threats that we've already discussed? And finally, external validity. To what population settings and times can we generalize this causal claim to? How representational is the sample? How representational is the manipulation and measures? So we see a very similar requirement or expectation for external validity between association and causal claims, but it should be noted that it's just not as a focus. Our focus on causal claims is internal validity, not external validity. It is important to recognize cultural psychology, and what I mean by this is that given effects have been found to not necessarily be the same when we actually look at across culture. So the first example is actually just looking at fish. If we show this to people in the United States or various Western countries, usually the first response is going to be, I see 3 large fishes. In other words, our focus is on the fish. If we show this exact same image to people from Eastern Asia or Japan, they're very unlikely to focus on the fish. They're more likely to go, it's a stream or it's an aquarium. They look at it as the whole. So that's an example where there is a strong tendency towards identification of the objects, fish, in the West, and identification of the whole, the collective picture, in Eastern Asia. Another example is the Muller-Lyer illusion. So if you grew up in the West with angular buildings and understanding perspective, then the line B is going to look longer than line A, even though they're the exact same length. And this is an illusion. And initially, this was thought to be a universal illusion, until it was found it's highly dependent on understanding Western art and living in a culture with Western architecture. In other words, hard straight lines. When we give this exact same test to people that grew up in a very rounded, basically a rounded non-Western civilization, and by rounded I mean they don't have large, tall, angular buildings, they have rounded huts. They see the two lines as identical. In other words, this illusion does not work on them. So again, that doesn't necessarily mean that all research is going to be culturally dependent, but we always want to check, are the findings that we're finding universal, or do they occur differently in different cultures? So finally, I want to end up, does a study have to take place in a real world setting? Absolutely not. Theory testing mode often requires artificial settings, but even laboratory settings can feel emotionally real, and this is called experimental realism. I probably mentioned that for a while as a graduate student, I worked in a research lab that looked at alcohol consumption and marijuana consumption. And in both cases, the lab itself was basically made to look either like a bar or a pot den, to be just brutally honest. Similarly, though people knew they were an experiment in Milgram's experiment, where they were being required to believe they were actually harming someone else, they all reported that they actually believed they were causing this harm, even though they knew they were in an experiment. So again, experimental realism is something we want to think about. It helps generalization, but it is a secondary goal to looking at internal validity when we're trying to make causal experimental claims.